All right. All right. So welcome back to the continuation of the first lecture. Okay. So we have this question on the screen, which says, show that the root of 2 and 1 plus the root of 2 are irrational numbers. How do you show or how do you work this out? So we use a method that is known as the contradiction method. So we have a lot of methods that you can use, but the simplest one is the contradiction method. Yeah, so how do we use a contradiction method? So by contradiction method, just from the word itself, contradiction. So meaning we're going to make a false assumption, not really false because we don't know whether this is, we're assuming that we don't know that the root of 2 is an irrational number. Now they want us to show that it's an irrational number. Anyway, so this question means, or in other words, it means that they know to say it's an irrational number, but they want us to show that it's an irrational number. So by the contradiction method, we are going to make an assumption. So we're going to say, assume that the root of 2 is a rational number. So we're going to make an assumption that the root of 2 is a rational number. So after making this assumption, we know to say all rational numbers, or for some number or something to qualify to be a rational number, we have to be able to express that given number in the form A over B. So for this root 2 to be called a rational number, it means that it should be able to be expressed in the form A over B, where B is not equal to 0. And we know that A and B are supposed to be members of what? Integers. And then apart from that, A and B are supposed to be what? Co-prime factors. So what do we mean when we say co-prime factors? It means that the fraction is in its lowest term. So we say there are co-prime factors, A and B are co-prime factors, means that the fraction is in its lowest term, meaning there shouldn't be any number that should go into A and B. Yeah, so this is our assumption. Yeah, so the next step will now be to check if really the root of 2 is a rational number, because we've assumed that it's a rational number. So let us now check. We are going to make sure that as we are checking, or how do we check it in other words, we have to make sure that it doesn't break any of these rules here. So we know that the first rule is that the denominator should not be equal to 0. The second rule is that A and B is supposed to be an integer. And then the third rule for this to be a rational number is that A and B are supposed to be in their lowest term. There shouldn't be any number that should go into A and B. So if we discover that there's a number that is going into A or B, then we conclude to say the root of 2 is not a rational number, hence it's an irrational number. Or if we find that the denominator is equal to 0, we do the conclusion that it's not a rational number, hence it's an irrational number. If we find that A and B, or maybe one of these numbers is not an integer, look at what I wrote here. I was supposed to write Z to represent integers, not R. Okay, so I'm supposed to write Z. Yes. So Z is the symbol for integers and not R. R is for real numbers. Sorry for that mistake. All right, so let's quickly move on. So the other, so this is our first assumption. This is our assumption. So the next step that we're supposed to do is to now check if the root of 2 is really an irrational, is really a rational number. So what I've written here is exactly what I just wrote here. So the first thing is that you make an assumption that the root of 2 is a rational number. And then the second part is you define what a rational number is by saying the root of 2, if the root of 2 is a rational number, it should be able to be expressed in the form A over B, where A and B are members of integers, and then b is not equal to 0. Then a and b are co-prime factors. So I've explained what co-prime factor means. And then apart from that, we can now prove that we can now check if really the root of 2 is a rational number. So how do we check? So I'm going to write the root of 2 here, and I will equate it to a over b. Then from there, I'm going to square both sides to get rid of the square root. So if I square the root of 2, I'm just going to remain with 2. Then this side, I'm going to have a to the power 2. This will give me a squared. And then everything divided by b to the power 2. This will give me b squared. So when I do the cross multiplication here, I'm going to get 2b squared is equal to a squared. So if you look at this statement here, it means that for you to find a squared, you have to multiply b by 2. This is what this statement means. It means that for you to find a squared, you have to multiply b by 2. Meaning if we divide a squared by 2, we're going to get what? B squared. So this implies that a squared is divisible by what? By 2. So we can say a squared is divisible by 2. Or if you don't want to use the word divisible, you can say a squared, rather you can say 2 is a factor of a squared. Yeah, so you can also say 2 is then a factor of a, or you can say a is also divisible by what? By 2. So you can either use the word factor or you say divisible. It still means the same. Okay, so we have discovered that a is divisible by 2. We've also discovered that a squared is also divisible by 2. Let us now interpret the last statement which I've written down here. To say a is divisible by 2. How do we interpret that? So we're going to say if a should be divisible by 2, then for you to find a, you have to multiply 2 by a number that we don't know. I'm going to call it k. If I say 3 is divisible by 5, so if I say 3 is divisible by 5, it means that when I divide 3 by 5, I'm going to get a certain number here. So now, since this a is just a variable, yeah, so this k is just a variable. I mean, this a is just a variable. So I don't know what this number is. So I'm just going to say if I divide, let me use a. So if I divide a by 2, I'm going to get a number which I don't know. So I'm calling that number k. So if I cross multiply, I'm having a is equal to 2k. So this is the statement which I've written here. And then the other thing that you need also to get is this same expression there. So I'm going to get this expression there, and while there is a, I'm going to replace by 2k. So I'm going to have 2b squared there is equal to, then I'll put 2k there while there's a, and then since a is squared there, I'm squaring that part. So I'm going to have 2b squared is equal to, when I square this, I'm getting 4k squared. So when I divide everything by by 4, I'm getting this side. If I divide 2b squared over 4, then this other side I'm dividing 4k squared by 4. This and that will cancel. So I'm going to get something like this. What did I write here? So we had a is equal to 2k, then you replace it there. Yeah, so okay, so this is what we're getting. So if you divide everything, let me divide everything by 2 instead, so that I leave b squared along this side. Instead of dividing everything by 4, I'm going to divide everything by 2. So I'm going to have b squared this side. Then this side, if I divide by 2 there, if I divide by 2, I'm getting b squared this side. And then this side, I'm getting 2k squared. So what this means is almost the same as what we had here. So what this means is that when you look at this statement here, it says for you to get b squared, you have to multiply k squared by 2. So what this implies is that b squared can be divided by b squared can be divided by what? B squared can be divided by 2, meaning it's divisible. B squared is divisible. B squared is divisible by 2. And then this also implies that b is also what? Divisible by the same 2. But if you remember very well, we said a and b should be what? Co-prime factors, meaning they are supposed to be in their lowest term, meaning there shouldn't be any number that should go into what? A and b. So we said if we find that there are numbers that can go into a and b, then we conclude that the root of 2 is not what? Is not a rational number. Hence, it's what? It's irrational. Okay, so we can write the conclusion. We can say since a and b are both divisible by 2, then a and b are not co-prime, they're not co-prime factors. Then if they're not co-prime factors, this implies that um, then we can say then, or you can just say hence the contradiction. Or if you want, you can write a statement saying then this contradicts with the fact that A and B are supposed to be co-prime factors. Or you can just say hence the contradiction, hence the contradiction, hence the contradiction. When you write this, you say hence the contradiction, then you finally write to say therefore the root of 2 not is not a rational number. It is what? It is an irrational number. Yeah. So this is what you do. And then for this other part, this one is simple. Looking at it, or since we have solved this one, so what you can just do for this question is that you do the same process to find that the root of, to prove that the root of 2 is what? Is an irrational number. So once you do the proving, you even write the conclusion for the root of 2. You also write the other conclusion to say the addition of a rational number, which is 1 in this case, and an irrational number results into what? An irrational number. Hence, 1 plus the root of 2 is an irrational number. So you do the same procedure here, and then when writing the conclusion for this one, you write the conclusion for this one first, and then you come and write another conclusion for this one separately, where you say, since the addition of a rational number and an irrational number results into an irrational number, therefore, therefore 1 plus the root of 2 is an irrational number. Remember the rules which I gave you on the previous page, these rules here. You have to put them in mind whenever you've been given that, such a question as what we had, which is 1 plus the root of 2. Remember what we said, addition of an irrational number and a rational number results to an irrational number. So this is what was happening here. So you just first have to prove that the root of 2 is an irrational number, and then you write this conclusion down here as your final answer. I hope everything is clear. All right, so move on to the next page. Okay, so this is an exercise which I was talking about. Yeah, so you have to submit this exercise before we have the next mathematics lesson. So in case you need more examples on this, I'm going to send you the videos that you can that you can watch, rather, which I've made with a lot of examples on this question and also this question, even this one. So make sure that you submit this exercise before we have the next mathematics lesson. Yeah, as shown on the timetable. All right, so like I said, if you have any questions, you want help in any course, yeah, the A-level courses, feel free to contact me on any of these lines on the screen. And this is the end of tonight's lesson. So make sure that you submit the exercise.